and the buoyant force. And density and the buoyant force has to do with Archimedes' Principle. And from the daily review today, we learned that the buoyant force that is acting on an object that's completely submerged. It can't be an object that's floating with part of its volume above the surface. But an object that's completely submerged and is floating midway in the water column, like a submarine. Archimedes' Principle states that the buoyant force pushing up on that object is equal to the weight of the water that is displaced by the object. So that is the volume of water that the object takes up. If you weighed it, that water would be equal to the buoyant force. The density of water is 1. Okay, I'll say that again. The density of water is 1 gram per cubic centimeter. And that is a given. It's kind of like it's automatically calibrated at, for pure water, 1 gram of it is equal to 1 cubic centimeter. That's the way they define the gram, okay, as the volume of 1 cubic centimeter of pure water. Now, if you want to predict floating and sinking, knowing that water is 1, you can predict that if an object will float or sink. If the object has a mass or a density that is greater than 1, the object will what? Sink. Yeah. If the object has a density that is less than 1, the object will float. And if the object has a density that is exactly 1.000, the object is going to be suspended in the middle of the water column. And remember the formula that we wrote down for density. Density is mass divided by volume. Now, for a giant submarine, when it is submerged, the density is still going to be less than 1 if it's below the surface. Density will increase if the mass increases or volume decreases. Okay, that's something that you want to keep in mind. Density will decrease if mass decreases or volume increases. So there's 2 ways to both increase and decrease the density of an object, using mass or volume. And we'll get into this during labs. Okay, buoyant force. The pressure on the bottom of a submerged object is greater than the pressure on the top. And the result is that there's a net force in the upward direction. And that's called the buoyant force. And the buoyant force always acts in a direction that's opposite to gravity, just like Matthias mentioned. And it makes an object have less weight, but it has the same mass. If the weight is less than the buoyant force, it floats. If the weight is greater than the buoyant force, it sinks. And if the weight is equal to the buoyant force, it hovers or is suspended within the water column. And here we have Archimedes' Principle. The buoyant force acting up on a submerged object is equal to the force of the weight of the volume of liquid the object displaces. Okay, so when it's floating, the buoyant force is greater. When it's sinking, the buoyant force is less than gravity. Okay. When the weight of the water displaced by the object equals the buoyant force on the object, it will float. Okay. All right. We'll stop there and get on to the lab. The lab today, you're going to finish up, first of all, you're going to finish the questions from the lab from yesterday, and then I will